Hello everyone, in this video we're going to be going over max flow graphs. So these are a type of graph that is directed and weighted. So each of these arcs between two edges or two vertices has a direction. So I'm going from S to this upper node, and I'm going from S to the upper node. I can't go back along that edge, and there's a weight to it. I can push 13 units of something through this edge, right? The other thing about max flow graphs is they have what's called a source, and that's denoted with an S, and a sink, which is denoted with a T. Now, generally speaking, the source only has arcs going out of it, whereas the sink only has arcs coming into it. Now, we can have things going into the source, but those are kind of less useful because that's where the origin of all of our stuff is going to come from. And we can have things coming out of the sink, but we want everything to go into the sink, so those edges would be, or those arcs would be less useful there. And so kind of what I'm talking about is the goal of a max flow graph is to get as much as you can from the source to the sink. So as much as possible from this S node to the T node. All right, so that's the goal when we're looking at max flow graphs. This was initially a problem, initially conceived as a problem when we're thinking about Soviet railway networks, but we can also think of it as pipes in a city's water system or sewer system, that sort of thing. We want to get as much from this point to this point as we can, just going along the network. And how do we do that? Right? So we do that with augmenting paths. This is a path from the source to the sink that adds flow into the sink. So if we have no more augmenting paths, we're done. We have found the max flow in the network. So if we have a current flow right now of 0 and we're pushing 0 through all of these different pipes, say, our first path, we can push 1 through here because this is the capacity. This lower number is going to be the capacity from S to this middle node. And then we have 1, so we can only push 1 through this edge, even though we have capacity of 6, but we don't have 6 coming out of here. We only have stuff coming out of the S. So we get 1 coming through here and 1 coming through this 6 capacity node. Right? So this is one augmenting path that is possible in this network. This is not the maximum flow of the network though, because we can add in more augmenting paths. So the next augmenting path we could add in would be up through that 13, and I could push 13 through there, but then the most of it would have nowhere to go because there's only 8 here, and then there's only 6 here and only 5 here. So through this entire augmenting path, I only am going to push 5 because that's the smallest thing that I get in the entire place. All right, so before in our last augmenting path, we could only push 1 through because that was at the start. In this augmenting path, we can only push 5 through because at the end we only have space for that 5 to go. And we don't want things to pool at our different vertices. All right, so now we have a max flow for this graph so far of 6 because we have the 1 from the first augmenting path and the 5 from the next augmenting path. Let's look and see if we can add any to that. So we have 1 coming from here, 5 coming through here. We could also do this and add 2 more coming up from S to this upper node, going down, and then instead of going down here, we could go over here and add through this way. So that's their next augmenting path, and we're up to a current flow of 8. And then we have 1 more augmenting path that we could add flow through. take a minute, pause the video, see if you can spot that path. All right, so that path is this path here of coming up from the S, going down, down, and then instead of going straight to the sink, going up and down again. Right, so the max flow for this network is 9 coming into the sink. This 4 plus the 5 here is the maximum flow from source to sink for this network. So I have posted a couple of problems in a worksheet, and so go do those, and I'll review the answers in the next video. Bye-bye.